Okay, is it audible? Is it audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay. Thank you. So I am coordinator
Yes,
Dr.
sir.
Dilip Kumar Chaube. Would like to wish you all a very warm good evening. So I would like to call our HOD CSE to say a few words about this activity. Okay, sir.
Honorable Director Sir, Professor Arvind Chaube of IIIT Bhagalpur, Coordinator Dr. Dilip Kumar Chaube of this Faculty Development Program, other dignitaries present in this online mode, and my dear participants. A very good evening to all of you. Let me take the pleasure to introduce the Department of Computer Science and Engineering in front of you. See, Department of Computer Science and Engineering of IIIT Bhagalpur has started functioning in the year of 2017. And since then till date, it is continuously involved in imparting the higher educations to the people of the country and abroad. So see, at present, we are having UG course, that is BTech in Computer Science and Engineering, MTech in Artificial Intelligence and Data Science, and PhD in Computer Science and Engineering. And see, the major research areas of this department is Artificial Intelligence and Machine Learning, Computer Communication and Computer Network, VLSI testing and circuit testing, computer architecture. So in these areas, almost 11 students are currently working in their respective fields of their PhD work under different faculty members of this institute. This, I hope that this faculty development program under ATAL scheme, namely Artificial Intelligence and Machine Learning in Healthcare and Agriculture, you are going to enjoy a great academic ambience. So I would like to call Dr. Dilip Kumar Chaube, coordinator of this faculty development program, to introduce our speaker, Dr. Bharat Kumar Gupta. Hope you will enjoy a great academic ambience throughout the session. Thank you very much.
So good evening to everyone. I am profoundly delighted to welcome the first speaker for this FDP, Professor Bharat Gupta. He is a well known for his wonderful administration, high achievements in work in the field of ICT, healthcare, Internet of Things, medical IoT, machine learning, etc. Apart from this, he is appreciated for his commendable contributions in NIT Patna and truly known for his academician skill. Now I am going to introduce about Professor Bharat Gupta. Sir has been involved in the field of education and research for the last 19 years. He is a senior member of IEEE USC. Dr. Gupta did his graduation in 2000 and post-graduation in 2003. He did his doctorate from University of Rome, Tor Vergata, Italy in the year 2011. He got the Indian Young Research Award from the Ministro dell'Istruzione dell'Università della Ricerca, MIUR, Italy. Presently, he is working as a professor in the Department of Electronics and Communication Engineering, NIT Patna, Bihar. He is also the professor in charge of Incubation Center, NIT Patna, and nodal officer for Bihar startup at NIT Patna. Professor Gupta is the chief investigator for the project scheme for financial assistance for setting up of electronics and ICT academies at NIT Patna, sponsored by the Ministry of Electronics and Information Technology, mighty Government of India. He has guided many undergraduate and postgraduate theses, 6 students have awarded PhD degree under his guidance, and 2 have submitted the thesis. Another 7 are working under him. He has delivered many talks in international and national conferences and workshops. He has published more than 85 papers in international and national journals and conferences. He is also the reviewer of many international journals. He was a member of the advisory committee in the National Conference on Emerging Trends in Electronics and Telecommunication Engineering, and has also chaired many sessions in conferences. He has organized the workshop at national and international level. His research area covers mainly wireless body area network, routing and MAC protocol for medical wireless communication, ICT for healthcare, Internet of Things, medical IoT, FM UWB communication technology, machine learning. Sir, welcome. Please hand over to you.
Thank you, Dr. Chaube. First of all, very good evening to all of you. First, I would like to say thanks to Professor Arvind Chaube, Director IIT Bhagalpur, for organizing such a nice FDP, and which is the topic is artificial intelligence and machine learning in healthcare and agriculture. So I'm very thankful that he has invited me, and the coordinator, Dr. Dilip Kumar Chaube, and the co-coordinator, Dr. Bablu Prasad Tiwari. Thank you so much for inviting me and allow me to share my views in front of the audience. So, am I audible, Dr. Dilip?
Yes, sir. Yes, sir. Audible, sir.
Okay, thank you. And as today's topic is really very vast, that is the artificial intelligence and machine learning in healthcare and agriculture. I'm sorry that I have not covered the agriculture, but when I discussed with Dilip, I have taken one case study of the agriculture also in my presentation, that I will show it in the second part of my presentation. So I'm just trying to share my slides first. One window. I hope that everybody is able to see my slides. Dilip, I'm not able to see anybody, so could you just give me yes or no?
Yeah, so please, everyone may put on your camera. Please, it is requested from you all, participant. It is requested from you all, please put on your camera. It will be good for sir. It will help to identify. Okay, please.
But how do I see that's the same problem I'm facing once again. I'm not able to see the...
Sir, your slide is visible, sir.
Okay, my slides are visible, fine.
Yeah, sir, just only we need to do F5, means we may do it Zoom, sir.
Then it will be visible.
Yeah, it will be in larger size, sir. It will be in full size.
Okay, one moment. Is it okay?
Sir, slide has not been zoomed, sir.
Okay, one moment. One moment.
Yes, sir. Yes, sir.
Is it okay?
Yes, sir.
Now?
Yes. Okay, sir. Well, sir.
Okay. So once again, very good evening to all of you. I can understand that everyone is tired, but I hope that I can give you some enlightenment toward that how the healthcare is beneficial with the this artificial and intelligent machine learning techniques, and how it is evolved, and what is basically the need of these technologies in the healthcare domain, and especially another one is the agricultural domain. So Dr. Dilip has already introduced me, so I'm directly come to my slides and giving you the a gist that what I'm going to present today. So this is the outline of my talk. That first I will give you the introduction that why there is a requirement of AI and ML techniques in the healthcare, what crisis we are facing in the healthcare domain, and where we can apply this artificial intelligence and machine learning techniques to improve our healthcare system and to improve the diagnosis and the entire ecosystem of the medical domain. This is one thing. Then we will see that what is AI and ML. We will learn about the concepts of AI and ML. I have tried to simplify. I have simplified the concepts, and with the help of pictures, I will try to make you understand that what is artificial intelligence and what is the machine learning. Then, in especially considering the healthcare domain, what is unique about the machine learning in healthcare domains, that we will see it, and what makes healthcare different, because there are a lot of fields where we can apply this AI and ML. And since this industry 4.0 evolution has come up, and we all are applying this all soft computing techniques to improve the efficacy of each and every machine, and the machines can work automated, and they can take the decisions, they can react, and they can work on this. And in that, this healthcare is not apart from the other domains, so everything can be applicable over here in the healthcare domain. But then we will see some of the use cases which is already implemented in the market, and the people are using it and this analyzing, and then we are improving these cases. And then we will see that what are the challenges of using the machine learning in healthcare, and some use cases which me and my students have tried to short it out over there. Sorry. Yes. So the pictures and animations and the data which I have taken it for my presentations are publicly domain. So I'm acknowledging all the people that who have provided this pictures, animations, and data in the public domains that I have taken. So I'm acknowledging all of them here. So if you see, as I told you that where is the requirement of this machine learning? If you see this map, and this map is just showing the numbers of the whole world. And basically this map is showing the number of doctors ratio between the people and the doctors in the different location of the world. So if you see that this is the numbers, which is the ratio, that number of people for which how many doctors are available. So this is what we are doing. And if you see in this red color basically, and the yellow color shows that there is a drastic the ratio is very high, and we require the more number of doctors over here. So in this, if you see that the best ratio is in the USA, where we can get this for every 500 people, we have one doctor in the USA. But in the worst case is that in the Central Africa, you can see it over here, that there are 50,000 people. There is one doctor among the 50,000 people. And this is the whole scenario, if you see. So it means that either we require to train the people, we have to produce more doctors, which is not feasible as such. So we need something which can assist to the doctors, and so that they can cater that many number of the people over there. patients over there. So if you see it here in India, we are not different, and we are also in the not in the good position. So if you see in the status of India, this is the healthcare crisis, and basically if you see the WHO recommend that one doctor for 1,000 patients is there, but on an average we are around 11,000 people uh, um, uh, are being treated by one doctor only. So that is the ratio we are doing, and it is not evenly distributed over there. So if you see it over here, the Bihar is the worst position. We can say that around 29,000, one doctor is available around the 29,000 people. Then Uttar Pradesh, then Jharkhand, and so on. Even but in the Delhi, it's we have a very good condition. But still, we are not in a position to meet the WHO standard, which says that one doctor for the 1,000 patients. So in that case, if you see this scenario, what are the techniques, how we can help our healthcare system to the uh, improve that the healthcare system. So in this case, uh, there is a need to develop the ways along with the help of new technology to bridge the gap up to some extent. So it means that we need to use the technologies which is available, which are evolving, and try to bridge this gap, and we can make, or we can make the doctors to be more efficient, or the caregivers or the nurses or these other staffs or the healthcare givers, they can take the help of these technologies or these I would say the technologies to to diagnose, to cater the needs of the patients. So it means that if suppose a doctor's strength we cannot increase, but the other medical staffs, if they can train, or if they can help at the initial stage to the patients, so the requirement, or I would say the number of patients going to the doctor is can be reduced. So we can send the patients who are having the critical situations or the emergency situations, they will reach to the doctors, or we can take the I would say uh, the we will take the decisions before that there your condition is going to be drastically reducing. You should visit to the doctor. So like we can pre-conclude, pre announce to the patients that okay, now this is the time to visit to the doctors. So that may the number of visits to the doctors may be reduced, and whenever there is a requirement, then only they will visit to the doctors, and the others healthcare staffs can support to the patients and to the doctors to improve the healthcare ecosystem. So if we see that factors enhancing growth in the healthcare technology, that how it happens. So if we see there is an increase in use of the smartphones, tablets, and other mobile platforms. Why it is happening? Because there is an enormous increase in the research or enhancement in the VLSI domain, communication domains, and the soft computing domain. So that will help to make some systems or uh, some assistant uh, to the patients. So that way we can say that increasing use of smartphone, tablets, and other mobile platforms are there. Second, that rapidly moving healthcare IT infrastructure in the industrialized nations. So wherever we talked about the developed or the developing nations, so wherever there is a developed nation, so the healthcare IT infrastructure is rapidly enhancing. So, and they are, because of the industrializations, and they are getting better services, and we for that we have to improve the all these systems. There are some policies by which the in the developed and developing countries where the governments are taking a lot of favorable decisions towards the healthcare domain. Rising demand of remote patient monitoring services, as everybody cannot reach to the nearest hospital, so we have to cater the medical emergency services to the remote places. So that is also one of the reason. Increase in the affordability in the middle income groups. So yes, the people have the affordability also. So that's why we can try to take care of the this proper healthcare, proper medications, and proper. We can buy the technologies by which we can monitor our physiological the signs, by which we can up to date day to day analysis of our health, and we can do the changes as per our requirements in our daily routine and life. So that's why we are saying that there is a enormous growth in the healthcare technologies, and these are the reasons by which we this growth has seen in the market. So I would say that due to this healthcare IT, with the favorable government regulations, have largely encouraged the adoption of the various healthcare techniques, in which uh, this due to of all these things, we have increased the various healthcare IT solutions, such as electronic medical records, e-prescribing systems, remote patient monitoring, and the wearable medical devices. And these factors or demands will boost the global market growth and the requirement of soft techniques. So if you see that these are the factors by which there is a demand, and it is affordable, so that everybody can use these techniques. So I would say that what is this AI in healthcare? This is, I would say, I will let you know what is AI a little bit later. First, you consider that is artificial intelligence in healthcare. Basically, it is a broader view in which the applications of the machine learning algorithms can be used with the other cognitive technologies, especially for the medical domain. So that's why this is the way how we are defining that AI in healthcare. So these techniques or the cognitive technologies or the machine learning algorithm will use the patient data and the other informations, and that can assist to the doctors and medical provider in delivering the more accurate and the treatment plan of the for the patients. So this, whatever the techniques that which we are talking about in the AI, that can help, uh, uh, that will help to make the healthcare more predictive, proactive, by analyzing the big data to develop, improve the preventive care recommendations for the patients. The meaning of this, that the big data over here is that point, like we are always collecting the data of the patients. So as I mentioned earlier, that we are collecting the patient data day-to-day basis, and then we can make the healthcare, the predictions and the proactive analysis of that about the patients can be done, and in that we can recommend the patients to be more preventive, towards the more preventive cares. Okay, so AI in healthcare can enhance the preventive cares and quality of life. So that way, this artificial intelligence will give you the preventive cares, means the care, the preventive care means like before the anything happens, like before the going to the emergency situations, we are providing the preventive cares. So that way improve the quality of life and the more accurate diagnosis and treatment plans that leads to the patient's better outcomes. So in that way, the the living standard of the patients will improve. AI can also predict and track the spread of infectious diseases by analyzing the data from a government, healthcare, and other resources. So this is another field where the artificial intelligence can help you to track and predict that where this infectious disease is spreading. We can analyze the data with the help of from the government, healthcare, and other sources, and say that what is the futuristic move of this infectious diseases. So we can take the preventive measures to stop and to and as well as for their medications. So this we have seen in the recently the COVID situation. So in that the people have worked a lot of AI and machine learning tools they have developed towards the towards the COVID-19 solutions. If we see what is AI, so I would say before AI, we should understand that what is learning. Because if we, in a broader sense, if I say the artificial intelligence, nothing but a machine can mimic as the as the human brain. So it means the machines can develop their sense as the human have. So the first thing is that what is learning? So we can learn something first with the help of acting or experience that thing. I will show you in the slides that the means is something is happening or something we are experiencing. This is one way of learning. Second thing is that knowledge or skill acquired by the instruction or study means this is also learning. The means as I'm giving lectures or I'm giving informations or in a class the teacher is teaching to us, we are acquiring the knowledge as well as the skills. Third, modification of behavioral tendency by experience, such as exposure to the contingency. It means that if we experience if we experience the environment, and on that basis, if we change, if we modify our behavioral way, that is also a learning. It means we can learn by experience, we can learn by knowledge or provided by the instructors, or we can learn learn with the help of the environment or the behavioral analysis of the environment. So if we see what is the act or experience, so if you see that in this picture, you can see that we are looking to the dots, and with that we are trying to experience that there are three colors dots, how they are moving. So this is one way. We are listening something, we are smelling something, we are tasting something, and we are smelling. So these are the five senses by which we can experience our environment, or we are getting we are learning that what it is like. If we see that colors are green, we can listen the music, we can smell it is good or bad, taste is good or bad, and it is soft or hard. So that type of experience we are gathering with the help of and that will help in learning us. Second thing, that how we learn, another way is that either we are learning by ourselves, we are doing with the help of experiments, we are learning it with the help of the teachers or the instructors. Third thing, as you know, that adaptation of the new situation, that we are modifying the behavioral with the experience. So as you can see it over in this, that as we grow up, we have changed, we have learned with the experience, and we have learned with the environment. So this is the three ways by which how we learn the system, and the same way we want that the system or the will learn. So if you say this is the learning, and if this learning becomes knowledge, and then finally we are giving it to the intelligence. So it's not that we know the learning and that the learning to extract the information from that learning or from that data is a knowledge, and these things when we club, that becomes an intelligence, and we are giving it to the machine. That is means it's not only the learning, it's a knowledge learning, and then we are giving it to the intelligence. So I would say the knowledge is the collection of skills, information a person has acquired through the experience. So if you see the previous thing, the learning, so with the help of this knowledge is nothing but the collection of skills and informations a person has acquired through experience. This is one thing. Intelligence is what? We define the intelligence in such a way that it is the ability to apply the knowledge. Means uh, that how intelligence is nothing but to gather the knowledge. It is that how we apply that knowledge is called the intelligence. So knowledge is wonderful in the sense that it can fade as the techniques and technology come and go. Means knowledge, if I'm learning right now the machine learning, this one of the techniques, but it can be improved, or another technique may come, but the intelligence is always sustains. Means the ability to apply the knowledge, which is intelligence, and intelligence is always sustained and it remains with the with us. So here we try to define what is artificial intelligence. This is nothing but the availability of a digital computer or computer controlled rover to perform tasks commonly associated with the intelligent beings. So it means artificial intelligence is what we want the any machine or a digital computer can perform tasks which are associated with intelligent beings. Means if I ask a robot to bring a glass of water, so it can, like if somebody is asking for a drinking, that it can be a room temperature. It cannot be very chilled or it cannot be very hot. So that means that intelligent beings, intelligence is being associated with the task over there. Okay. So now what is we have to see two slides, which is where this origin of AI comes. So origin of AI is in the year 1956, in which two scientists, that is the Marvin Minsky and the John McCarthy, they have organized a conference in 1956, and they brought the researchers who are interested in intelligent machines. Means initially they thought about they can develop the machines who can perform, who can think, or who can take the decisions. And then total, if I say the next 20 years, we are virtually working in this domain, and all the advances in AI was what happened. Okay. So what is actually in a different way, I'm just trying to make you understand in a more better way what is artificial intelligence. So Wellman in 1978, it says that the automation of the activity that we associated with human thinking is called the cognitive modeling approach, and it was Wellman has given this definition in 1978. Kurzweil in 1990, he says, the art of creating machine that perform functions that requires intelligence when performed by the people. Means this is called the Turing test approach, and I will tell you that what is this Turing approach over there. Then, so first thing is that we have talked about the systems can think like human. This is one. Second thing, systems can act like human. So we have to make the machines who can think like human, and after that they can act like humans. Similarly, the systems or the machines that can think rationally, that is the Charnik and the McDormand has given this definition: the study of mental faculties through the use of computational model. That is the laws of thoughts. That is the how we can think rationally, whether this water is hot or cold. That way, rationalism should acquired by the machine. Then systems that act rationally means they can take the decisions what we have to do. So Lugar and Stubblefield, this is they have given the rational agent approach, in which the whether the system that act rationally or not, and basically this is the I would say the branch of computer science is concerned with the automation of intelligent behavior. That we have to give the automation, and in which the intelligent behavior, or they can take the decisions based on the sensing the environment around us. So that is the thing. So now we will see that what is the thinking like human. Thinking of like human is that if suppose you have to take a decision whether this color is okay or this color is okay, whether this dress is okay or that, it means you have to think like human. You can take or you can decide that what is good for that situation and what is best for the person. So that will help to take a decision in the healthcare domain, that what diagnosis that we have to do, what prescriptions that which we have to perform, or what is the possible disease may come, and what is the possible solution for that disease. Okay. Second thing is that acting like human. So it means that first we have seen that thinking like human, and then how we are talking about acting like human. This means the Alan Turing in 1950, he did a test. Can machine think? Can machine behave intelligent? Means we want that this can be taken care, that I would say they can take the decisions whether it is good for that person or not. Means hopefully the people have seen or I would say the operational test for intelligent with the imitation games, means like which can imitate that what is required, what it's showing, and they can means they can do the caring of the things. So here acting like human means that you can care you can like in this picture, as you can see, it is taking care of a cat with a with this action. So now we will see that rational thinking is what. So rational thinking, as I make it this block down. So like if suppose you have an issue, so first, based on this information available with that issue, we will do a logical thinking based on the first impression that the issue. That is called a critical thinking. That whatever is coming to us, and we are thinking in that instantly, we are thinking that how it is happening, why it is happening, but it is not that. Whenever we process this information, that logical thinking based on the next impression. It means that whenever we are gathering the information, our logical thinking will be biased, or I would say will be modified or will be improved, and then finally we give the opinion on that. Like I would say, when a doctor is seeing the patient, so if suppose I will take that you have a fever, so it's not that you can just give a Calpol to the patient, but you have to gather the information that from the last 2 days what you have done, whether you have what other problems you are having. So taking care of all the information, and after that we have to make a logical logical thinking, and then we have to create an opinion that, okay, maybe you have a cold, or maybe you have something else by which you are getting this fever and all. So that's why this rational thinking comes. So it means we have to think about the more informations, and that will help to taking you the decisions. So this is what we have seen till now, that it means the artificial machines, they have a I would say they have a uh, thinking like human, acting like human. Then we should say they should have a rational thinking. Then says the machine can also act rationally. If you see in a broader view, so here at this point, we can say a artificial intelligence, any techniques which can enable computer to mimic human behavior. So human behavior, it means it has to uh, learn, it has to act, it has to rationally thinking, and then only it can behavior like a human. The machine learning, which is the subset, or I would say it is a branch, sub branch of artificial intelligence, or it is a subset of the artificial intelligence, in which help you, which can learn from the data, identify patterns, and make decisions with minimum human interventions. So it means that machine learning uh, is a subset, or it is a sub branch of artificial intelligence, which is based on the data or the patterns, and based on that we will take a decision, and in that decision human intervention, it should be minimum. There is another subset of the machine learning, means that is called a deep learning, which makes computational of the multi-layer neural networks feasible. So it means that we have to talk about the neural networks, in which how the neurons are working, which way they can mathematically attached, and then single layer, double layer, triple layer, multi-layers networks, that which we have to make it, and that will help to take the decisions more accurately, more towards the realistic side. So if you view this whole, the first artificial intelligence, within that machine learning, and then within that is, I would say, the mm, deep learning. So second thing, first we have seen artificial intelligence. Now we will see that what is machine learning. If I say the automating the automations, means getting computers to program themselves, is the machine learning. What is the problem that which we are facing, that we cannot write the software for all the problems or all the data. So what we have think, that why can't we make a machine which can learn from the data? So it means if I talk about a traditional programming which we usually do, in which there is a data, there is some rules, we give it to the system to give you the results. But in the machine learning, as I told you, that we cannot make the programs for all. So for that, what we are doing, we are giving data. We know that what is the results, and on that basis we are making the rules. So it means that if we are making a rules based on the data, we don't have to write the programs in such a way. We are doing we are taking the decisions, or based on the data and the results which is available with us, and making a rules on that. Machine learning process basically is what? Gathering various data from the various source, and we have to clean the data, because to make it the homogeneity, then model learning, then model testing, and finally the results. So this is a very general block diagram for the machine learning processes. So if you see that how the machine learning flow uh, is like that, smart programs can learn from the examples, as I told you. So we have a training set, we have new data. So some are supervised, some are unsupervised. Then we are extracting the features, machine learning algorithms that which we have developed. grouping into the object, predicting model, annotate data. So this is what we do in the machine learning flow. So I will just try to make it clearly, distinctly clear that what is supervised learning, what is unsupervised learning, and what is the reinforced and what is the reinforcement learning. Okay. So if you see that this first block diagram we have already seen over there, second program for the supervised learning is that we are giving answers. It means we are giving the results and the data, we are making the rules. And the unsupervised learning, we are giving simply data, and based on that we are making a rules. It means in the supervised learning we have the some known data are there, and on which that we can train our models, and then finally we are giving the new data to predict that what is there. What is reinforcement learning? There is a reinforcement agents are there, reinforcement environment is there. We do perform some actions. If we are going in the right direction, we'll get the rewards, or sometimes if we are not getting in the rewards, there is a punishment for that. So that's why we are developing the reinforcement learning. This is the thing, like where how we do machine learning. As you know, they are I have already told you, supervised, unsupervised, and the reinforcement learning. In the supervised, we do the classification, the regression, and then in the classification, that is the diagnostic. It means that whether the person is having disease or not, customer retentions, that whether how we can the activity of the customers will help us to know the behavior of the customers, and then that way we can retain. Image classification, identity fraud detections, regressions, in that whether we are going where the use data is there, weather forecasting, market forecasting. So I'm just telling you that even in the supervised learning there are different algorithm classification regressions, and that where we can use them. Similarly, in the unsupervised learning, we do the clustering that will help to the recommended system, target marketing, customer segmentations. It means we make the clusterings of the array, dimensionally reductions, feature. This is the structure discovery, meaningful compression, big data visualizations. So that type of applications we can do it. And reinforcement learning, basically it's a real-time decisions. Whenever we have to take a real-time decision, we go for a reinforcement learning, game AI, robot navigations, skill acquisitions, learning task, and all. So this is what we do. So that is the examples of the reinforcement learning. Now we will see at this stage that why the use of machine learning in the healthcare domain is required. We'll see that is since 2008, the electronic health record adoption is increased 9 times. So based, if we know that the electronic health records of the patients, and how we can utilize, how it can be useful to the patients, how it can be useful to the doctors, how it can be useful to the government, how it will be useful to the pharma industry, how it can be useful to for the predictions of the disease and all. So that is there. Because these all things cannot be done by the human, so we need some techniques by which we can do the analysis and all. And the purpose of that, it's a because whenever we talk about this electronic health records, there is a huge number of the data are there. Yes, anything?
Sir, as per ATAL schedule, means ATAL norms, we have to give 10-minute break to participant. 7 to 7:50 lecture, then 10-minute break, then from 8 to 8:50 lecture. So we are giving you 10-minute break. So please join before 2 minutes by 8. Okay, 7:58. So there is a break for 10 minutes. Please, if you are going to leave the session, you are not going to get a certificate. 80% attendance is mandatory. I'm telling you. If you do your attendance will be 80%, then you may join in offline mode, and you are going to get kit and all that, and you will get the certificate will be issued to you. Neither you are, and we are also going to conduct one test. So please listen carefully each session. Based on the session only, the test is going to be conducted. on last date. We will announce the date. Okay. So please join before 2 minutes by 8. Okay, sir. Thank you, sir. We'll have
Okay,
break for 10
so I will take a break.
minutes.
मतलब हुआ है, मतलब 8 साल में नहीं हुआ है।
So our resource person is has joined right now. He is online. So sir, you may start the lecture, sir.
Yes, Dilip.
Yes.
Okay, just a moment. Let me share it once again. So, yes, so participant, we have left it here. Why to use machine learning? Because we have enormous data which we have to handle it. And for a human being, it is not possible that it can be handle this whole data and take a decision and find out some fruitful informations from this. So this is the reason why we use machine learning. It's not that we are lazy. We are not just saving the energy. The purpose is that because we sometimes don't have expertise exists. Like in this Mars expedition, we don't have any information about the Mars. So for that, where we don't have the information about the place or environment, we can use the machine learning techniques which can help us to take the decisions. Okay, so sometimes, so the first one is that if suppose we are not expertise in that domain, so we can try to find out some fruitful informations from that. And humans can explain their expertise. Like if suppose I'm speaking, that somebody is listening, but it is very difficult to say that who is speaking. So speech recognitions, if we can't do that, we have to use this machine learning techniques. If suppose we have to give the customized, personalized medicines to the patients, so in that also we can use the machine learning techniques. Like if suppose what is the history of this patient, how it is behaving, what are the other problems, medications going on. So this, considering all the aspects, we can make a personalized or customized model for that person. This is, or sometimes if we have a very huge amount of data like genomics, it's very difficult to read and understand what is the DNA significance and all. So in that all situations where we don't have the expertise, where if we don't know about the environment, if we have a large amount of the data, or if we have to make something to be personalized or like that, for that we can go for the machine learning techniques to improve the decisions, to improve in the decisions. So the main thing is that if we see that digital health data is very in diverse natures, like we have some lab tests, proteomics, we have images of these, we have vital sign informations, we have genomics, sometimes we have a mental and social media data. So if we collect all the data and take a decision, so we require some soft computing techniques, that is the machine learning techniques by which we can take a proper decisions. So if I tell you some use cases where we have to use this machine learning and this. So very first we will look into that is the remote patient monitoring, that is the delivering values across the healthcare system. So if you see in this whole pictorial view, that these are the EG, temperature, the pulse rate, glucose, SpO2, weight. They are taking it with the help of some sensors, this data. And we are acquiring this data, and we not only acquiring, we are always monitoring in the sense when we do some analysis on this data which we the vital signs which we are measuring or collecting this data, if we apply some algorithms of computer techniques on this data, then only we can say we are monitoring the vital signs. So this is what we are monitoring an acquisition, and then we are sending with the help of any of the communication technologies. We are sending it to the cloud or something where this decisions can be done, and based on that we are giving this data to the new innovative health services, where some predictive models, preventive models, or some monitoring models can be developed, and this can be given to the clinical portals by which the physicians, nurse care manager, or authorized parties can view that data, so that this whole things is an automated, and it can be monitor the patient, it can take the decisions, and wherever it is required, we can help them. So this is one of the use case of this AI and machine learning in the healthcare domain. Another one is that whenever we talk about the DNA part, the genomic parts, in which like some structures are there, whether it's very difficult for a human being to recognize that what is the DNA structures, and what type of genomic should come over here, so that with the help of machine learning techniques we can predict, and we can just make it these things. If suppose wherever we require the very accuracy, means like human error cannot be tolerated over there. So naturally there the machines operated things can be used, and in this one example is the brain, this blood clotting in the brain can be the operated with the help of artificially intelligent machines, and do the operations over there. So this is the some examples which I have given you where we can use the AI and the ML over there. So this is remote patient health monitoring, where the use data are there, where the accuracy is required. So we can go with this AI and ML things. Now, what is if we go for a healthcare, so what is the uniqueness about the machine learning in healthcare? So first is that the quality of the health services and the availability to treat the complex disease constantly with the improvements. So first thing is that whenever we talk about the quality of services, we require or to solve the complex diseases, we require some help, or some machine help which can help us in taking the decisions and all. If suppose we need fair and accountable diagnosis, we require machines or with machine learning algorithms. And sometimes we have to find out the subtypes of diseases, then only we require. Whenever we have to take a life and death decisions, this machine learnings are required. And there is a wide variety of the data, then we have to go with machine learning algorithms. So this is the areas where we can use the machine learning. So this is the machine learning for healthcare sectors, like first drug discovery and manufacturing of this, where we can use this machine learning, medical imaging diagnosis, behavior modification, smart health records, clinical trial and research, crowdsourced data collections, better radiotherapy, or outbreak predictions. So in all the areas we can take in use of this cognitive and the soft techniques to take the better decisions in the health domain. So this is the because this machine learnings can be used anywhere, but what makes healthcare different from the other data? So the thing is there is a little level data. We don't have any level data that if like in my one of the use cases, I will explain you that EEG or the cataract, it's very difficult to say diagnosis the disease and what type of disease are there. That type of data is not available with us, so we have to go with some techniques. Motivate semi-supervised learning algorithm. Sometimes small number of samples, we don't have the huge number of data by which we can train our machines. So that is there. So for that we need to think deep learning techniques. The learn as much as possible from the other data. So we have to take care of the healthy patients, the data, and the machines has to learn themselves. So this is the thing. Models the problem carefully. We have to the problems which are very complicated, we have to model them in a proper way. Lots of missing data, time variability is there. Need of data sharing agreement sensitivity. Nobody wants to share their data one place, one agency to the other agency. So there are a lot of problems that which we are facing, and that makes the healthcare data is different from the other data. So I will Dilip. Dilip, are you able to listen me? Dilip? Okay, not a problem. So I'm just showing you one futuristic thing. With this video, I have taken it from the internet. Hopefully, you can just visualize this. Are you able to listen the voice? This is basically, we are talking about the pre-diabetic situation.
Yes, sir.
Yes.
Yes, sir.
Are you able to see the video?
Yes, sir.
Yes, sir. Yes, sir. Audible, sir.
Okay. Please have a just look to this video first.
Yes. Yes, sir.
So you have seen this video, I hope. Hello?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So
Proceed.
Yes, sir.
in this video,
Yes,
what
sir.
I've shown you about the futuristic healthcare delivery system. This is a complete ecosystem which the people are trying to develop. This video is around 2012 or something, 2010, where when that time we have looked for the to develop this all this. And in this, some of the things are already developed, and some we are making try to make it in the developing stage. So here in this video, that what we have seen, there is a diabetic patient, so who is always monitored, and the activity is monitored. The people are suggested their activity, the what activity they have you have to do, then when we have to review for the doctors, and when what type of medicines you have to eat, and then the medications also taken care of by this. The doctors will get the the feedback from the patient side, and they know that what is where they can see their electronic the healthcare data records, and they can see that how you are performing. So this is all they are doing in this video, and that is the futuristic healthcare ecosystem that which we are trying to develop it over there. So in this, with this, there are some few cases which are already developed, and I'm just telling you the some of the use cases which the people are using, and some of the companies have developed. And after that, I will come to the some other parts of the use cases over there. Okay, so the first use cases is the patient behavior modification. See, patient behavior modification is that because whenever you have some lifestyle diseases, you have like we call it as like diabetic, the obesity, and the I would say the anxiety. So this is all are the lifestyle diseases, we call it. So we in that, what is required, that how we have to avoid we have to change our lifestyle so that we can improve improve the I would say the to minimize the effect of these diseases on the body. So they says that like the many prevalent diseases are manageable or even avoidable with the help of this patient behavior modifications. So like type 2 diabetic, obesity, heart diseases, and some skins can be to avoid by practicing a healthier lifestyle. So how it is happening? Patient behavior modification means like whatever the activity that which we are doing in day-to-day activities, these all the sensors, like when the person was running, or he or she was walking, what is the speed, how long he has walked, what she's eating, how she has taken care of all data, all type of data that which we are collecting. And based on that, we aggregate this all data, and we make some machine learning algorithm that will connect to the health devices and sensors, so that we can guide them during this transfer journey. Means like we can say that, okay, like suppose if we suggest, because of the high sugar and the obesity, that you have to walk for 2 kilometers, like today you have walked for like 1 kilometers, you need 1 more kilometer to walk to maintain the daily routine. Today you have taken that much calorie of the diet, you require much more less calories, so just avoid this. Like, so this type of patient modifications, behavioral modifications are required, and that type of thing is available, and that is called in that they have made the how to reduce the smoking habit with the help of the smoke beat. This is smoke beat is a I would say it is a app by which they can tell you that how many cigarettes you have taken in a day, or they can warn you, or they can do that. So how we can do it? Like SmokeBeat passively collect users smoking statistics. This is hand to mouth gestures using a smartwatch accelerators. So like it's like whenever we go for this action, so with the help of smartwatch, they can accelerate, they can see that how much the I mean how many times you have gone through the smoking, whenever it is a continuous. So a lot of this behavior analysis they will do. And this smoke beat uses this data to provide the real-time cognitive behavior therapy incentives. Also, like if suppose if we reduce uh, uh, the number of cigarettes, so naturally there are some incentives are there. So that is, they are also helping it to use this help to change their behavioral analysis. So this smoke beat analyzes individual smoking data with peer establishing a social network. So this is one of the kind of use case. This is a smoke beat, and by which we can go monitor the patient's behavior, and we can help them to reduce the habit of the taking a cigarette and all. So this is one type of use case. In that, the lot of data that which we are collecting, we can make a model, and then we can train it, and accordingly we can predict that how many number of cigarettes you have taken per day, whether you are reducing it or not, whether you are taking, and that the information we can send it to the doctors, and accordingly we can, and how much you have taken that signature, that also statistics we can cover up, taken up with that. Second one is the virtual nursing. Like as you have seen, the patient is sitting, lie down on the bed. There is a monitor over there which can taking care of this, all the informations, collecting all the vital signs, and draw the graphs and all. And on that basis, the medicines are also assisted with this. So it's a sort of virtual nurse, means there is a person who is taking care of you, personalized care on 24/7 basis. So because you can, as I told you in the very first slide, that there is a more number of caregivers are required for the patients, and we have a huge dearth of this. So we need something of virtual nurses like that which can solve these problems. So this is the virtual nurses can interact with the patients more regularly than human nurses and answer all the questions between the doctor's visits. Means they have a chat box also, which can be which can listen the answers on, based on that answers they can reply to the patients in that way. So this is one use case, that is the Molly was made it. And this is a example of virtual nurse. This is a female type of, which would challenging to monitor on the spots. So basically day-to-day or remote monitoring is there. This Molly or like this will take all the data of their blood pressures, all vital signs connected to W, and this can be analyzed. This data can be analyzed, and on that basis, the doctors can increase or reduce the dose of the medicines. And the second thing, Molly can this basically the avatar can recognize the speech, verbally answer the patients, and it can offer a chatbot for the private discussions and all these things. So this is another use case of this in the healthcare domain. The third one is the medical imaging. This I will show you that where the two use cases I have developed. One is the cataract detection, and another one is the EEG analysis. That is the epileptic analysis of that system. So in that, what we do, the medical images are be given as an input, and the efficient or analysis can be done, and as well as within a shorter period of the time. So this is another use case, which is called subtle MR. And this is the subtle MR is the software which they have developed, and which can help you to improve the quality of MRI protocols, that what we are doing, that what is happening or as acquired. And this is the subtle that enhance the view of the things, and it can also suggest that what is being observed in this image or like that. And basically we process the image because human error is too much, so we are denoising, resolutions enhancement, and then it can help you to read it in a more clearly. And this US leader, that is the RedNet, is in outpatient imaging, can have 335 centers across the country, accelerated its protocol by 35, so for adopting the subtle MR technology. So this is a technology by which we can understand, or we can improve our the viewing MRI viewing capacity and take a proper decision within no times, like that. Another one is identify the high risk patients. So identify the high risk patient is like heart attack, the patients who are having going to a heart attack. So they are high risk patients. So it has to be monitored and it has to be taken care by this. So with the help of combining this machine learning power, pattern recognition, and automation, clinician can considerably reduce the time taken to identify the high risk patients. So they can analyze the vital signs, they can analyze the previous reports, and on that basis they can just distinguish between the patients who are at the high risk. So this is the detecting the high pressure with Unipath and the Emitech. This is another the use case, which is Unipath is an AI and robotic process automation enabled automation platform, and which can help a healthcare to provide the automatic patient analysis. So they have lot of sensors. They can optical character recognition, natural language processing is used in that, and the robotic process automation has been done. And on that basis, it can tell you that whether the patients are at high risk or not. So robot-assisted surgeries, yes, this is the another field that people are looking for, and in which the Snehal surgical, in which we have heard a lot of things like robot-assisted surgeries can be done with the help of AI and machine learning, and it can be incorporated into this. So improve the outcomes of the surgical operations, like that. So with this Snehal surgical systems, they have made it. Snehal surgical system is a console-based multi-arm surgical system that allows surgeons to remotely control. So if you see this is the machines that which we are controlled, and the doctor can sit from a remote and can see the vital sign, as well as they can operate the patients in that way. So the system heavily relies on the machine learning and deep learning models to bring the most challenging healthcare ideas to the reality. That is what we do, and they can track the eye movement of the doctors, and accordingly they can zoom or unzoom where the surgery is happening, like that. So this is another use case of this there. Then drug discovery in the pharma industry, because drug discovery is an expensive and long process. So we need to mix up a lot of trials and all the things. So machine learning algorithms are used in the drug discovery process for the following purpose: minimizing the clinical trial durations, identify combination of the existing drugs, discovery of new drugs based on compound testing, and finding new uses of the previously tested substances. So the thing is that because it's for a man or for a human, it's very difficult to remember this all such things, and that what is already the tested substances are there, what type of combinations we can do, new combinations we can do it, so that all things can be with the help of machine learning algorithms we can make it. So there is a finding cure to disease with Google DeepMind. There is another use case with Google DeepMind they have developed, and that is called the AlphaFold, that automatically predict the protein structure built in Google DeepMind and revealed in 2020. Recently they have announced it. Reliability prediction of how different protein interact with each other in the immense biological breakthrough. as it can significantly accelerate drug screening and development. So this Google DeepMind will help you to predict the protein structures and what are the structures are there, and how we can improve in it. Right? So that type of how the structure improved, and so that can help you to cure the disease and all is there. Hospital management optimizations, because there are a lot of patients are coming, a lot of doctors are there in careful treatments are required. So this hospital management optimization is also very important in the healthcare institutions. And in this, the optimizing staffing with Globus.ai. So Globus.ai is a Norway-based company who has helped in the healthcare institution to streamline the staffing, because where to appoint which nurse, and when the doctor is coming. So this all management is taken care, because for a man to manage all the things is very difficult. So that's why the Globus.ai, they have come up with a hospital management software, and which can help you to do all the task. There is a disease outbreak predictions. So this the example I have already given, the corona. Nowadays, huge amount of data can be collected from satellites. So the one example is that is the malaria outbreak. So generally, the third world countries, they have a lack of infrastructure. So we need to know, with the help of images, satellite imagery, with gathering the data from different means, and analyze the data that how it is spreading, where it is spreading. So that will help you to allow to take the precautions and to minimize their negative impact and save lives for the thing. So any, like we have seen in the corona 19 also, COVID-19, and this disease outbreak predictions have been happened. So we have also seen that the people are collecting the data from the mobile locations, whether you have visited the infected area or not, where you are moving. They can trace you, and they can tell you that you don't go over there, so that it can be stopped. Or like if you are visited by chance, if you have visited that place, they can suggest that you should start taking the medications and all. So that is this way we can restrict, and we can minimize the negative impacts of these outbreaks. There is another type of, this is ProMed, reporting disease outbreak online. This is a program of monitoring emerging disease. This is also another use case, which can help you to offer the online real-time monitoring system showing outbreak of infectious worldwide, and any exposure of toxin affecting human and animal health, like all types of things. So you can check, all these things are available on the internet, and this will help you to understand that what type of applications that which we can generate, and what is existing, and what more we can do it in this domain. So data provided by the ProMed is aggregated by the health map to visualize disease outbreak in every country. So this is the ProMed is a use case. It can gather the data, and it can map it on the health map, and on the worldwide, and they can let you know that which country is having this disease outbreak or not, and which way it is spreading, how it is spreading, and what rate it is spreading. So we can get all the information, and we can take precautionary steps to stop at that moment. So this is the second last medical diagnostic that which we have seen, that we need. They can gather the information of the initial vital sign, and based on that they can diagnose it, and then doctors they can suggest to the doctors, and the doctors will take the help of these diagnoses, and based on that they can do the further diagnosis of this. So this is the predicting syndrome with phase 2 Gen is an app, a machine learning enabled facial recognition software that helps clinicians to more accurately diagnose the rare disease. So that will help you to because generally this medical diagnostic in I would say the skin diseases are there, so where we can by just seeing the image skin, we cannot predict that what type of disease are there. So with this type of machine learning algorithms or apps or like the applications, if we are able to generate, that will help to assist to the doctors to take a proper decision. So detect this is the evaluate so this is basically this will help you to diagnose the rare diseases, or this can help you to assist the doctors in taking the decisions on the diagnosis. Another one is the health insurance, because health insurance is another, because a lot of people are taking the fraud claims, fraud detections, and all these things. So that things can stop, and machine learning algorithms and help to stop the frauds done by or fast the claim process, and faster the customer support to these insurance claimers, and that will help to all this. So that's why this health insurance, basically these are the things we can take the data, and based on that we can take the give the services to the patients and the hospitals and the caregivers. This is another use case for this health insurance, that is the Maya Intelligence, that is the Temple University Health System, a nationally recognized academic health system, is partnered with Accolade, a company provide Maya Intelligence platform to help patients of the most appropriate healthcare coverage options. So that will this Maya Intelligence, this is the use case they have developed, TUHS, and this will help you to the patients that what is the optimal coverage they can get it, what type of insurance they should take it. They can understand the problems of the patients and the hospitals, and on that basis the things will be suggested to the customers. So that this way the companies have gained a lot of profits and all there. So this is the another type. So basically even though if we talk about this all use cases, there are some challenges that which we have to face in this. First, the lack of data, the clean data we don't have. There is a the datas are not transferable to one agency to the another agency. There is a biasness. The person who is training the machine learning algorithms may be biased, or inevitable creeps in that things. And lack of strategies. There is no strategy that how to collect the data, what are the nomenclatures, what are the features that which you have to put it into that. And I would say there is no the future strategies that is as there, that how to collect the data, how to prepare the data so that easily the things can be implemented. Lack of in-house expertise. Yes, true. We have a lot of complex technologies as machine learning, and in which the medicals, it's very difficult. We need the technical skills, excellent technical skill, and the deep understanding in the medical science. But most of the times, it is very difficult to I would say very difficult that everybody should have that much understanding about the medical science too, and they can help in developing the machine learning so that it can be a productive output. So that's why we call it as a lack of in-house expertise is there. So these are the challenges that which we are facing in the healthcare industry. So if I say at this moment, I will take you some of the use cases. The first, I will tell you the one which is yes. So this is the use case which we have developed, that is the visual assistant. Basically, we have make this a smart assistant for the visual impaired ones. So what is we are looking that there is a camera installed, that part is remaining. So we have the camera installed in the stick, and which can see the pictures and what is in the frame, and on that basis it can read, it can uh, find out the object within the frame, and then objects with the objects it can be framed to a sentence. Okay, so this is the case which we have developed, and in that we have we like if you see this picture, if a blind person can see this picture, it's a no information for him, but we want to help the visually impaired patient, and it will say basically the sentence, a boy is playing with the sand, or a boy in the blue shirt is sitting on the sand, depending on how one choose and interpret the image. So that's a difficult part, but at least the person can know that the person is near to the sand. It is a boy who is having the wearing the blue shirt and playing or sitting, whatever it is doing. So that's naturally we require a lot of data to train our model to predict in a proper way. So what we did in this, if the first thing is that we have identify the immediate environment in the frame. So like suppose if the person is the camera, if in this picture, if you see that they are recognizing the first, there is a person, there is a sport ball, there is a basketball bat, and it means that we are trying to recognize the things in that picture. After that, putting all together to frame out some sentence, and building blocks are there, and changing the text into the received captions into the spoken words, and then we can use the Google API, which can read out the sentence, and it can pronounce it to the people. So if you see in this picture, this is the person, basketball, ball. So the sentence, maybe a person is playing a basketball, and speak may will produce spoken towards the sentence as to be generated over there. So in this, I will tell you that the CNN, that is the convolution neural network we have used, and the different hidden layers that which we have, the convol, ReLU, polling is there, and we have done the feature extraction and that do the classification. And here, one thing, once we need only this feature vector, so that we will remove this layer over there. Once we have the feature extraction, we can give the input to the this LSTM, that is the this word LSTM, and then we images, and then we finally this input CNN model, LSTM, and dense, and then finally we get a output. This is the approach that which we have used in this. So after performing this model whole, we have wrote the codes in this, and it's something like this is the UI we have developed, in which, like, suppose in a frame, the person, a man in blue shirt, is holding a video camera. So this is what the UI we have developed, in which, like, if a person is seeing that what it is doing, so it can be pronounced, and that will be helpful to the visual impaired people. And if you see, there are some results we have done it a lot of. So this is the picture, and it says a dog is running through the grass, a brown dog is running through the glass. So this is the we have predicted with the greedy search and the beam search we have used. So they are the different types of sentence, but at least we should have that what is in this picture is known to us. Similarly, in this picture, greedy search we have put it, so a young girl is swinging on the swing, and beam search, a little girl swing on a playground. So there is a different types of sentences which we are making, and at least it will helpful to the prediction. Similarly, over here, a young girl is pink shirt and eating sandwich, and that is the thing. So our accuracy is very good, and at least now we have a very less data. That's why we are not able to train it much, but we have to use a bigger database to train it more accurately in that. And the people who are interested to work on this part, I have given the get it link over here where the database I have written, and they can make it complete by themselves by using this codes over there. So this is the one use case which we have developed. I will tell you the second use case. Second use case is for the sign language recognition. Sign language recognition means it is also for the impaired patients. So they means this is for the blind patients, I will say. So they can means we need some systems who can read out these things for them. So these are the sign languages like A, B, C, D, E, F, G, and in that this we have trained the system with the help of the CNN. This I will tell you that where. Yes. So this is the image classification. We have the convolution, and then we have you again use the convolution neural network for the image analysis, and finally, with that we got this results. This is the classification accuracy that which we are getting, and we can read out that what is it is telling. So that will help you to the visually impaired patients, and they can read out the sign languages over. So this is the another type of use case which we have developed. And another one, I will tell you one thing. Okay, yes, this is the one. This is the third one, in which again it is a image analysis part. That is the diabetic retinopathy. We have taken the image of the retina, and then we can predict that what type of disease it is there, whether it is a diabetic retinopathy, age related macular degeneration, cardiovascular disease, or glaucoma disease. So again, in this we are giving the fundus images, image for segmentation, feature string. We have classified the training, classification, decision making, and the diagnosis we have done. So if you see, this is the proposed methodology that which we have given, and we have developed this one algorithm for that. We are giving the data set of this, which is pre-processed. It means the color channel estimation and the image cropping, we have done it. And then we done the segmentation to enhance the fuzzy, with the help of the enhanced fuzzy C-means clustering. We have done this. After that, hybrid deep learning techniques, we have tried to feature extract and this classification. And in that, we have used the DenseNet 121 and the ShuffleNet V2. And we are predicting that what is the output of that. And our accuracy is very good. So I will just tell you the results of this. This is what the pre-processing. This is the pre-processing of the images. This is the segmentation that what we have done, and this is what we are classifying the images. And on that basis, we are finding out the performance metrics of this. This is the accuracy, specificity, recall, and the F1 scores. So this is what we have find it out. Okay. So this is the third use case which we have developed. And now I will take one use case especially for the agriculture part. Okay. So give me just 2 minutes, Dilip, for this. So here what we have done, we have, yes, Dilip.
Yes, sir. Yes, sir. Okay, sir. Sir, we are having 10-minute time. Then we will interact with candidates as per norms of ATAL.
Yes. So may I give? Will I explain this or not?
Yes, sir. Explain, sir. Explain, sir. Because many are from agriculture universities.
Yes. That's why I took it. So basically, we have done the design and implementation of the sensor networks for context-aware irrigation system. So context-aware irrigation system means that depending on the moisture level of the soils, our irrigation system will work on that. And in that, I'm not going to give you this whole detail of this. I'm directly coming to the, this is, one moment, sorry. Yes, so this is the basically the conceptual part in which the solar powered pump and the solenoid valves waits for a command from the coordinating node to be actuated. So this is basically a solar panel pump, and whenever there is a requirement of the water, it will start, and accordingly, based on that, how much water we have to give it, they will give it. So in this whole field, we have deployed the sensors. The sensors deployment of self-fabricated sensor pod prototypes is like this, that how much water is coming out, and we have taken out the this field. We have put the moisture sensors, which can sense the moisture level up to the 5 centimeters of the soil. So based on that, how much water is required to be put in the field, they will take the decisions. So this is the way, and in that the first one is sensor pods deployed all over the field. Second thing is the sensor deployed. It can completely dependent on the solar power. It establishes a network for communicating with this, and then it is coordinating with all the nodes over there, and based on that, the coordinator will take the decisions whether we have to give the water or not. So this is, we have implemented it over there. In that, this is the process flow and the whole diagram, that where we have to do it, and how we are interfacing all the things, and on what basis we are taking the decisions in giving the water. And this is basically the model, real-time models which we have developed it. And in that, as you can see, this is the whole system which can sense the moisture levels. Over here, we have put it in the 3 different types of sense, moisture level sense, and based on that, it will start the water pump, and how much water is need to be required. Okay. So this is the thing, and sometimes we can take this temperature, humidity, soil moisture, node lifetime analysis. We can do it, and this is the whole system which can take a decision of the moisture analysis. So this is one of the application use case which we have developed with the help of this artificial intelligence, that how much the moisture level, and on that basis how much water is required to be, and that is, we call it as the smart irrigation towards this. And this is the relative soil moistures that which we had, and for the time we have calculated this graph comparison between the common irrigation and the smart irrigation, that how is the improved irrigation can be done with the help of the smart irrigation points. So this is the use cases I have discussed. So if I just summarize the things, yes, this with the help of the this artificial intelligence, I would say yes. So this is what I have already showed you, the use cases which we have developed. What is the existing use cases in the healthcare domain, and what are the use cases which our research group has developed in the healthcare domain, and as well as one very this example of the smart irrigations, that which we can do it. So point is that these I would say the artificial intelligence or the machine learning that can help to can be applied in the areas where the self-care or the prevention or wellness is required, care delivery is required, clinical decision support systems has to be required, diagnosis where we have to do the automatic diagnosis required, chronic care management is required. So these are the areas where we can apply this algorithms to improve and make it to the automated systems. So with this work, And one more thing, as the population is increasing, as the advancement is in the technology, uh, I would say there is a uh, lot of improvement is required to improve the technologies, and which can help to help the medical caregivers. Okay, and that can help in strengthening our innovation type, because new development of the applications are coming up, so that will help you to develop the new innovations in this field also. Yes, thank you so much.
Thank you, sir. So participants, if you are having any question, you may ask them, sir. Please. Anyone?
हाँ सर हेलो हेलो
Yes, you may ask, Ram Vikas.
yes sir sir, is there any AI and ML for doing X-ray work, because people are facing huge problem, because first of all with their bad condition they have to go to doctor, and thereafter then again they have to change the shop and go to X-ray, means different place for X-ray. So is there any research related to this?
Means I didn't get you, like whether the machines has to be improved or the places have to be improved.
नो सर सर क्या होता है ना, पेशेंट पहले फ्रैक्चर मान ली हो गया, तो पहले डॉक्टर के पास जाता है, उसके बाद फिर उसको बोला जाता है एक्सरे के लिए तुम वहां पे जाओ, तो जनरली लोगों को चेंज करना पड़ता है। तो ऐसा कुछ टेक्नोलॉजी के रिसर्च जो कि डॉक्टर के मतलब वहां पे खुद कर सके, उन लोगों को चेंज ना करना पड़े इधर से उधर जो पेशेंट को जाना पड़ता है।
Actually, this you are talking about the infrastructure. Yes, I'm agree with your point that whenever somebody goes with a fractured case and the doctor just suggests you that you have to go for a X-ray, and for the diagnosis that how big the fracture and how small the fracture is. So your point is that yes, we can develop a machine which can be I would say which can be cheap, so that everybody can be implemented. And second thing, we can make that machine to be smarter. It can be imagine machine. Like if you see nowadays when you go to the dentist will take put it a X-ray machine over there, and in the I would say in the laptop they can just check it that where you have to hole and where you have to dig out. So similar type of machines can be used for this X-rays also, and where in the this monitored or like in a laptop, the softwares can analyze this imaging part and can say that this is the fracture, and this big or this small is the fractures. Yes, this can be done, and there are but I have no idea that whether the people are working on this field, but this is really a good winner. But in that you have to work on the development of that such type of machines, which can be portable, which can be cheap in cost, so that every doctors or every place can be they can purchase that.
Yes, is there anyone more?
Okay, sir.
Sir, I have a question, sir.
Yes.
So you talked about DeepMind, Google's DeepMind, how it uses DeepMind to identify protein structure.
Actually,
into the AlphaFold.
Yes,
so can you tell me? Sir? Yes, sir. So I wanted to know, sir, how it uses DeepMind to identify diseases.
The protein structures
and protein structures. Yes, sir.
Actually, if you see the literature, because basically what we are doing, we are making a model, and with the existing database we can first train our model. Once the model is trained, then we are giving input to that the new inputs, and accordingly it can predict the thing. Similarly, in the protein structures, what is there? They are the existing, we know that what type of protein structures are available, and the system, the machine or the systems can be trained with the existing protein structures, and whenever they do the analysis, and on that basis they will say whether this is a new protein, what is the protein is ruptured, what type of proteins are required. So on that basis they takes the decision on the protein. The Google Deep can will take a decision on that part.
So one more question I have.
Yes.
So the use of pattern recognition on using UiPath. Can you, sir, tell me about this a bit more? So how does it happen?
In the UiPath.
UI, yes, sir.
एक minute, just let me just come up with that. Basically, if you see, this is, are you able to see the slides? No. Basically, this UiPath is an AI and robotic process automation, which is help you to the large healthcare provider automated patient analysis. So this is in that they can go for a pattern recognition. They will take the vital sign as a input, and they have a means, I would say they will just say that if you suppose if you are having a running nose, if you have a the fever, or if you have it, so we can predict that you have a cold. Or if suppose they have a chest X-ray over that, and the analysis of the pattern, the X-ray can help tell you that, okay, whether this what is happening to your chest and all the things. So this all input is given to the this I would say this this UiPath part, and then they take the automated patient analysis will be done in that. Because it will tell you in that, like, it's not only this one or two things are there. Means it will collect your vital sign. This is one thing. It will take the X-rays of your body. It will take a MRI scan of your body, and then it will collect all the informations of this analysis, and on that basis it will tell you that what is the what the problem you are having, and then what disease you are facing, what are the possible solutions can, and then after that it will referring to the final to the doctor who will take the final decisions of that part. Yes.
Okay, so I think there should not be. Yeah, is there any more question? Okay, so no question. Okay, so okay, thank you so much, Professor Bharat Gupta sir, for your valuable time. Your expert talk has provided us with invaluable insights about artificial intelligence and ML in healthcare. How the big data is used in healthcare. What is the definition of learning and four approaches of AI, and why and where we use ML like patient monitoring system. You introduced us to the uniqueness of ML in healthcare, and you beautifully explained the various types of ML techniques like traditional programming, supervised learning, unsupervised learning, reinforcement learning, and your videos about AI system improving and easing down the use of medication for patient was remarkable. The introduction to various use cases from virtual nursing to drug discovery and various other revolutionary idea has made us realize the potential use of AI and ML in healthcare. Your project for the visually impaired patient is really helpful for the visually impaired community. The use of solar pumps and the irrigation system employed with moisture sensors is really brilliant. I'm sure the participants have attained a better understanding of all these topics. Thank you again, sir, for taking out your valuable time to impart us with your knowledge. Thank you, sir.
Thank you, Dr. Dilip, for inviting me and sharing my knowledge or share my experience with the participants. I hope the participants are ignited with the use cases which I told, which is already available in the the public domain, they can just dig out this specific use cases and find out much more details over there. And if suppose they have any doubts, they can always discuss with me in any time. Thank you so much.
Thank you, sir. Thank you, participant. Okay, we'll meet by tomorrow. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
So Dilip, I can leave.